Good afternoon. Good afternoon, everyone from Jeddah, Saudi Arabia. This is Nawal Al Hamwi. Firstly, I want to thank our sponsors, StreamYard, for sponsoring our event. We definitely couldn't have done it without their help, so thank you, StreamYard, once again for helping our community. I really hope you're enjoying the Flutter event, Flutter Day events as much as I am, and hopefully you're enjoying the Flutter Hackathon too. Now, speaking of the Flutter Hackathon, this is a reminder that voting is still open. So all the best of luck to those participating in it. Now, we're so happy to be holding this session today with Nash Ramdial. Nash is a Trinidadian software engineer and author with experience working on projects for both enterprise and startups. He's been an avid Flutter developer since summer 2017 and serves as the lead editor and admin of the Flutter community Medium publication. Currently, Nash is a mobile developer at Junto Foundation. When he's not writing code, you can find him at the nearest coffee shop. The stage is all yours, Nash. Good luck.
Thank you for the introduction, Nawal. It's great to be here. Welcome, everyone. I see we still have a few people coming in to the stream, so we'll give them about a minute again. So today we'll be looking at responsive design in Flutter. Um, a quick overview of what we will be covering today. We're going to have a brief introduction. We're going to look at some of the basics, and we're going to work ourselves all the way up to some more advanced stuffs with working with constraints. So there's something in this talk here for everyone. If you have questions, please leave them in the chat and we'll get to them at the end. So that said, why should I care about responsive design? As a developer, if you're coming from the mobile world, why should I care about making my applications look good and scale for websites and desktops? Well, customers expect the website and apps they use to scale to whatever device and screen size that they're using. Poorly designed apps can leave users disappointed and affect the perception of your service. In fact, 50% of internet users say they won't recommend a business if their website is poorly designed, according to a recent survey. Now, this is even more so for Flutter, because as a Flutter developer, not only can you target mobile applications with your app, you can also scale your application from the same code base to target desktop and web applications. Now, working with responsive designs can have some challenges associated with it. For one, you need to set up and think about media queries for your layout and your UI. You need to rethink your navigation structure, because what looks good on an app may not necessarily scale and fit a desktop. So you need to have a serious look at your application flow and see if, okay, this looks great on my phone, but how can I make this work just as good on a website? How can I make this look just as good as on a tablet? All of these are questions you need to have as a developer. And of course, supporting multiple screen sizes and multiple platforms adds a development overhead. As a developer, you're already working in a really tight timeline and schedule. And now the toss of adding support for multiple screen sizes and orientations can drive you a bit crazy. How does Flutter handle this? Well, out of the box, if you use a row and a column for your layout, then by default, you have your UI will scale and resize itself to fit the window that it's housed in. Now, this is a great start, but as you can see in this example, it's not perfect. For example, you have your UI can overflow on certain devices if you do not handle this properly. But lucky for us, Flutter has this notion of a flexible built right in. And if some of you are web developers, you may hear the term flexible and you may think Flexbox. And you would be 100% right to think so, because flexibles in Flutter is very similar to the Flexbox model on the web. So let's look at some code. Here we have some code of how we can adapt our UI for a horizontal and a vertical layout. Now, the first thing we're doing is we're using a media query, and we're getting the size, and we're looking at the width. Next, we're using some conditional logic here to compare the size that we're getting and display the correct widget for that size. Now, this is a great example of how you can leverage conditional logic in your UIs to hide and show UI elements based on a breakpoint. In the case of media query, as a web developer, this should be really simple, because you're accustomed to using these terminologies in the web. You use a media query to set CSS breakpoints, for example. Here, we're using it to get the width of the screen, where we set our own breakpoint to show and hide our layout. The code for this, for the vertical and the horizontal layout, is also pretty simple. In fact, we only use two key widgets here that are important to make this all work. We use a column for a vertical layout and a row for a horizontal layout. But the critical widget that we use inside of these are an expanded. Now, an expanded is a widget you can think of that resizes its child to fit and adapt to the space that's available. It also has a property called flex, which is a number you can give it to tell it how much of the space it should occupy. So for example, by default, an expanded has a flex of 1, meaning both of these UI elements would size themselves to be exactly 50% of the screen. If you were to change that and have a flex of 2 and a flex of 1, then the first expanded would take up 2/3 of the screen, and the final expanded would only take up 1/3. So in this way, it works in proportions of your total available space. Now, if we implement this code in our application and we do a bit of refactoring, let's see what this gives us. Here we can see the UI nicely resizes and changes its layout once it passes the breakpoint that we've set. Everything is not as it seems, though. We fixed our UI stretching, but what about the overflow that we were having on the button and the column? We didn't do anything about that, so let's play around with this UI a bit more and see how it reacts when the width and when the height gets smaller. As you can see here, we're resizing, and as the height gets too small, we have our friendly overflow. But why is that? We've added these expandeds. Why don't they fix our overflow automatically as well? Well, let's look at the code and let's see what's really going on here. Now, something that jumps out is we have these two size blocks and they're using a fixed height for the spacing. Okay, it's interesting and it's a common UI practice. So why does this matter? Well, on the device that we develop with, and for screen sizes that's close to or larger than that device, it's fine because our UI scales and works perfectly on those devices. However, if you were to run the same UI in a smaller screen on a smaller device, then we have a bit of problem here because our layout extends further than the bottom insets of the device. And that, of course, will trigger our friendly little overflow error that we see in our UI. But luckily for us, it's not too bad to fix this. The solution is very, very easy. So let's break down what we want to do here. First, we want our spacing to adapt as we resize the window. We want something that is flexible, something that can adapt as we manipulate the available space. And we want a widget that is size independent. We don't want to be hard coding our sizes throughout our application. So how does this look like in code? Well, as you might guess, we have a flexible widget that we can use to replace our size box. And a flexible widget is really similar to an expanded. In fact, an expanded is actually a flexible under the hood with some custom properties set. So an expanded is just a flexible with a tight constraint and a default flex of 1. But one of the key differences is an expanded, like we talked about earlier, forces the child to expand and take up as much space as possible, whereas a flexible does not impose these constraints onto its child. The child is allowed to take up as much or as little space as possible while also still being able to resize and scale nicely. And of course, like an expanded, a flexible acts on the main axis. So if you were to use this in a column, it would act vertically. In a row, it would act horizontal. The next widget that we're using here is a fractionally sized box. And again, the name kind of gives you an inkling to what it does. Like a sized box, it allows you to size your child, but using a viewport fraction. And you can think of this height factor as a percent of the total available space. So this height factor goes from 0 to 1 and would represent a percentage of the available space. It also has a property for sizing the width. And as a bonus, it even has an align that you can use for an extra level of control and granularity for laying out your widgets. In this case, we're setting the height factor to a percentage of the available screen size. Some other really great widgets that you can use for your layout are wrap. Wrap is a really great widget that works similar to a row and a column, but it has the added benefit that when the size gets smaller and the constraints get tighter, it would automatically reflow your widgets to adapt to the changing size. So in a way, a wrap is a really great starting place for developers wanting to add some responsiveness to their application. Another really good one is fitted box. A fitted box scales your widget to occupy and obey the box fit that you provide. And the box fit, again, if you're coming from CSS land, it should be really familiar. You can tell it to cover the entire screen or fill a proportion. So these are some really great widgets that you can use to enhance your UI. Now, here's another really cool example. I'd like to draw your attention to this member row. In this row, you notice that we have a slight overlap with the UI elements. And at a first glance, you may think, OK, then that looks pretty simple. Maybe I should use a stack and position these elements in a way that they overlap. And at a first glance, that may not be a wrong approach. It's pretty simple. They're overlapping, so a stack makes sense. But we can use one of the widgets that we looked at in the previous slide, like align, and we can use it to position these elements. And what's great is an align allows you to position your elements vertically, horizontally, and with the addition, it has a height and a width factor that are also fractional arguments. So in this example, we set the width factor to be 80%. And with the UI elements set at an 80% width factor, we have a 20% overlap with the different elements, giving us this nice members bar here for our card. Here's another example using an aspect ratio. And here we have some simple boxes. And as you resize these windows, the boxes maintain their aspect ratio regardless of the window size and how you manipulate the window. And this is great because you can place an image in here, for instance, and have it resize and scale the image nicely. Or you can have cards in the content area where you can have your cards resized nicely. So there are tons of great widgets at your disposal that you can play around with and experiment with to achieve different UI patterns. So those are widgets, but we also have builders. Now, builders in Flutter cover everything from providing your widget tree with values to providing you access to constraints. In fact, Flutter out of the box has tons of builders that you can use for different things like animations, working with streams. However, when you're working with UI and laying out your children, there's two main widgets that you may want to look at, a layout builder and an orientation builder. Now, for the purposes of this talk, we'll look at a layout builder. So what is a layout builder? Well, according to the documentation, it builds a widget tree that can depend on the parent widget size. Now, the key here is the parent widget size. So why does this matter? Why do we care about the parent widget? Why can't we just use the media query to obtain the size again? What's the difference here? And why should this affect how we use and lay out our widgets? So here's a bit of background. The media query size that you access represents the physical window size. Now, this is really good because it tells you the actual size of the window the Flutter view is running in. So it's great for setting global breakpoints. So if you want to set a breakpoint for a tablet device, then you can examine the size property and set your breakpoints. But using the global window size in a nested widget may not be the greatest idea. In fact, to understand why, we need to have a quick look at how Flutter works under the hood. If you're not familiar with Flutter, here is a brief rundown. Your constraints from the parent goes down to child, and the sizes of the child goes back up the tree. Once this is complete, the parent sets the position of the child. Now, with your constraints running down, accessing the global size property does not follow this paradigm and does not follow this pattern. So it can cause, in some cases, for your UI elements to break if it scales. Here's a quick example of using a layout builder to build a resizing desktop window. Notice here, as the device gets smaller, we're doing a very similar thing to our previous example where we resize and reflow our elements, but this time we're using the values that the parent widget provides. Now, all this talk about breakpoints and responsive patterns may have you going, okay, that's great, but how do I actually set these breakpoints in my code, and how do I actually know when I should transition from a phone to a tablet? And for that, we can look at how Material Design and the Android spec does it. In this graphic, provided to us by the developer.android.com website, they actually have common breakpoints and values you can use in your code to transition your UIs between the different devices and form factors. So for example, on a screen size of 480, we can use a 4-column layout, but on a screen size of maybe 840 to 960, we can use a 12-column layout. So you can use these values to help you better understand when you should transition your elements. It's important to note that while yes, you can use this as a guide, you can also set your own custom breakpoints and do what's best for your application. So it depends on the effect and how much different device form factors you're willing to support in your code base. So let's do a quick recap. What is everything that we've learned so far? We've talked about using a flexible in a row and using an expanded in a row in a column to help you size and position your children in a way that they resize once the available space is manipulated. We've looked at using a fitted box and a line to resize and position widgets based on a fraction of the available space instead of hard coding fixed values into your code. We looked at how we can use a media query size property to determine and set global breakpoints for different devices and screen sizes. And of course, we talked about a layout builder and how you can use the constraints from the parents to lay out your widgets based on the available space actually allocated to you instead of reaching for the global screen size. And of course, we talked about avoiding common pitfalls like hard coding your sizes and being mindful of how and when you access your global size properties. And of course, we talked about before you reach for more complex layouts and widgets, we talked about asking yourself, is there a way or is there a widget that does something similar without having to implement a complex widget in our application? And the example we used, of course, was using our align to create that overlap in our member card. So these are some great points that you should refer back to when you're building responsive UIs. So always start with something as simple as a row and a column before moving into the more complex stuff. because these widgets are so very powerful, and you can use the different properties in them to create some really amazing UIs. Finally, we have some resources that are out there that you can use to help you debug and test your UIs for different form factors. Now, DeviceToPreview by Alois Daniel is a really great example, because you can run your app with a device preview in a tablet, for example, and automatically debug and switch between the different layouts with your code without having to switch emulators. So this is a really great way to quickly test and validate your UI as you're building it. And as you can see here, he has properties for changing orientation, the localization, and a whole bunch of other properties. So this is a really great way to quickly test and validate your app. Another really great package that we can use is responsive scaffold. If you remember it earlier, we talked about having to rethink your navigation structure as your UI changes. And a responsive scaffold is really helpful for that, because once you lay out your widgets based on the scaffold properties, as your device form factor changes, it automatically hides and adds menu items to show and reveal your elements. So it's a really great way to reduce the amount of workload required to make your application responsive and work on a wide variety of different devices. Finally, here are some common links that you can check out. The Flutter widgets repository actually has an example of setting up breakpoints and using them in code. So this is a really great resource that you can check out and refer back to. And Navigation Rail was a brand new widget introduced not too long ago into the SDK by the Flutter team for adding a navigation rail to your application. So maybe on smaller devices, you can show a bottom navigation bar, but as you transition, you can move your UI elements from that bottom navigation bar to a navigation rail that's better suited for tablets and desktop devices. And of course, the Flutter gallery example was recently updated to support responsive design and responsive widgets. So that brings us to the end of this talk. I do hope it was informative and you learned something. So if there are any questions, please feel free to ask them in the chat.
Thank you so much, Nash. Definitely, it was super awesome. Yes, so now we will be taking questions from the chat. So if you have any question, don't hesitate to write them in the comments section. Okay, cool. Lady, okay, she's basically she liked the talk. Thank you.
Thank you. Now, I did only mention Layout Builder here, and we didn't really go into code examples, but in cases where you want to do more complex stuff, I would advise that you check out widgets like custom single child layouts and custom multi-child layouts. So this talk can easily be extended to more complex topics, but since the audience was targeting intermediate to beginners, we didn't really go into them. And a caveat I should mention for Layout Builder is, if you're using a Layout Builder in your UI, you cannot use an intrinsic widget within your Layout Builder. It needs to be outside of your Layout Builder. And this is you can't use an intrinsic widget outside your Layout Builder. You can only use it inside. That's my bad. But this is a side effect of having the constraints passed down.
Okay, so thank you, Nash. Mark says, great job. Can you remind us once more why you should not hard code, then he says hard code sizes.
Yeah, so you shouldn't hard code your sizes because as your widget changes and as your device screen changes, these sizes are fixed. So if you run your app on a tablet with a fixed size of 42 pixels, this 42 pixels will be the same even for a small iPhone 5, which would cause your layout to overflow because the size of the screen would not be able to support that fixed size. So ideally, you want to use something that's fractional and based on the size that's available to you.
Interesting. And Scott is asking, with the responsive scaffold, where those drawers on the left and right side that show all the time on wider layouts, but behave as normal drawers when narrow?
Yes, they do. So the drawer and the end drawer would be shown on larger layouts as part of the main UI, but on smaller screens, it would transition to that hamburger menu and items menu that you can use to expand and close the drawer as needed.
Mm-hmm. Interesting. So Robert is asking, how do you look at the slivers for responsive layout? Do you not use it, or do you have a complete separate implementation for that?
Robert, with the really technical question here. So it depends on the layout that you're doing, right? Slivers are great. You can write your own custom sliver, and I do believe on an episode of The Boring Show, Philip and Hixie wrote a custom sliver. But it depends on what you're doing because you can do some really interesting stuff with some of the delegate methods that are available to you. But if you want something more custom and something that adapts while you're scrolling, then you may want to look into implementing a custom sliver. So short answer, it depends on what you're trying to do.
Cool.
Is it possible to detect full screen toggle/changes? So if you mean like rotating your device as a screen change, then you can use something like an orientation builder, which gives you an orientation property whenever the device screen changes. So yes, you can use widgets like those to be notified whenever the screen changes.
Interesting. Um, okay, so when do you want to use flexible and expanded widgets?
Great question. So the key here is when do you want your UI to automatically be as large as possible? So if you want so for example, if you have an image in a row and you always want that image to take up as much space as possible, then that's an example of where you'd use an expanded because the behavior an expanded forces on its child would always ensure that the image takes up as much space as possible. Now, if you have a widget that has some sizing on it, like for example, the card, then you'd want to use a flexible because it ensures that the widget can resize itself if it gets smaller, but it does not force the widget to be as large as possible, like an expanded was. And of course, if you want to manipulate the different constraints, then a flexible would give you those properties and allow you to do so.
Okay, so we have no more questions. So I think that this is a wrap up for today. Thank you so much, Nash. Thanks everyone for coming, and see ya.
Yep.
Bye.
Thank you for having me. Bye.